mean values. We know that here our data must be follows either normal distribution or Gaussian distribution. So here those distributions must be have the variance as well as the mu, it means that mean value. So here variance is the fixed value, mu value, it means that mean value is not known value, unknown value. So here we need to take the unknown parameters theta. Here theta is nothing but our mean values. Okay. So similarly here y is a random variable because it is defined in terms of the random variable z only. Okay. So why we are considering y as the random variable? Here y is nothing but x union z. Here x is observed data and z is the unobserved data. Here z is a random variable, that probability function is depends upon our unknown parameters as well as the observed data. So here y is formed with the help of z. So we simply conclude that our y is also a random variable. Okay. So coming to the value of h, here the h denotes the current hypothesis. So the value of this particular hypothesis is the values of our parameter theta. Just now we taken that the theta is the unknown parameter, so the theta contains the mean values of the distributions. So here those set of mean values are considered as our hypothesis. Okay. So the value of h bar denotes the revised hypothesis estimated on each iteration of our EM algorithm. So in our EM algorithm we need to guess the something, and we need to check that whether those guessed values are converging or not. If they are not converging, again we need to go for the estimation step as well as we need to go for the maximization step. So in the estimation and maximization step we are updating our hypothesis. So here updated hypothesis is denoted as the h bar. So this h bar is gained in our iteration of our EM algorithms. And here generally our EM algorithm such as the maximum likelihood estimation hypothesis h bar, by seeking the h bar that maximizes. Okay. So here our aim of EM algorithm is so maximizing the h bar, maximizes the h bar. So within that, so we need to maximize the likelihood estimation hypothesis h bar. So here this is the estimated value. So if you observe this one, here we have three components. One is the probability of y conditioned on h bar and logarithmic on this probability value, and based on this we are maximizing this. It means that we are taking the estimated value. Okay. So here we simply define a function that is q of h hyphen conditioned on h. Here h is our current hypothesis and h bar is the updated hypothesis which is gained after iteration in our EM algorithm. So here this one gives our estimated value. So here estimation of logarithmic of probability y conditioned on h bar. Here we know that y is our total data, and generally this total data is considered as a random variable because that total data is having unknown observable values z. So we simply conclude that y is also a unobserved data, or we simply say it's a random variable. So to guess this particular random variables we need to consider our known observable data. So we simply define our q function as estimation of logarithmic of probability y conditioned on h bar and conditioned on h comma x. Here this x is indicating our observable data. So because here our full data must be depends on x, because this is a portion of our full data y. Okay. And coming to the steps which are involved in our EM algorithm, here these two steps are giving our general version of EM algorithm. Here these two steps are concluded based on our previous discussion. So here we need to repeat this these particular steps until convergence occurs. So here in the step 1 we simply estimate, we simply call it as the estimation step or E step. So in this we simply calculate the q of h bar conditioned on h. Here the h is the current hypothesis and h bar is the updated hypothesis. So this one be gained after iteration, after one of the iteration in our EM algorithm. So here calculate this one with the help of current hypothesis h and the observable data x to estimate the probability distribution over y. So here this is our function, so which we discussed now. And coming to the step 2, in the step 2, that is the maximization step. So in this particular step we simply replace our hypothesis h by the hypothesis h bar that maximizes our function q. Okay, so here h is replaced with the h bar. So here h bar must be maximizing. When we need to replace this hy by the h bar, so whenever this h bar maximizing our hypothesis, maximizing our function q, okay, so then only we need to replace h with the h bar. So here replacing h with the h bar means we are doing the updation of our hypothesis. So in the estimation step we are estimating something, and in the maximization step, so we simply update the estimated hypothesis. Okay, so these are the two steps. Here these two steps are repeated until the convergence is occurred. If the convergence is not occurred, again we need to repeat these two steps. Okay, so this is the general version of our EM algorithm. And coming to the applications of EM algorithm, so here we have some list of applications. Here generally our EM algorithm is the basis for many unsupervised clustering algorithms, and it's also used for train the Bayesian belief networks as well as radial based networks, and it is widely used for the learning in presence of unobserved variables, example missing features and class labels, etc. So it means that if we have the unobserved data in our training data, so then those unobserved data is gained with the help of this particular EM algorithm. And fourth application is it's used for the variables whose values is never directly observed. Never directly observed means those variables are treated as the latent variables. So here with the help of provided general form of probability density function governing these variables is known. It means that with the help of a probability density function, so we simply derive the values for the latent variables. So it means that the variables which are not directly observable. And this EM algorithm is also used to find the plenty of use in our natural language processing and computer visions too. Okay, and also it can be reconstruct images in the field of medicine or structural engineering using this one. Okay, so these are some set of applications. So here this is the information regarding our EM algorithm. And coming to the self-assessment questions, the first question is EM algorithm includes two repeated steps. Here what is the second step? So we know that the second step of this particular algorithm is the maximization step. And what are the applications of EM algorithm? That is the second self-assessment question. So here EM algorithm is used to find the latent variables, and it is also used to train the Bayesian belief networks, and it's a basis for the clustering techniques. So the answer is the all of the above. Okay, so thank you very much.